Hi all, in this video I am going to explain you about a two-stage op-amp. Before getting into this two-stage op-amp, let us try to review the single-stage op-amp what we have been discussed in our previous video lecturer. Our single-stage op-amp is going to produce the small signal current produced by an input pair to flow directly to the output impedance. That is nothing but the differential input pair, whatever the voltage we are going to apply, that is simply going to get converted into an current and it simply flows through the output impedance. The gain of this topology is therefore limited to the product of input pair transconductance and output impedance. That is nothing but an GM into an RD, the gain. Okay, in order to increase the gain in our single stage op amp, we have used an cascoded stages. Okay, if we increase the cascoding stage in that circuit or a telescopic amplifier circuit, there we are going to be getting an increase in the gain, but it is going to be affecting our output voltage swing. In some application, the gain or an output swing provided by the cascoded op amps are not adequate. In the sense, if we take any applications, suppose if I want to get an I gain as well as an I voltage swing. Okay, that is not provided by our telescopic op amp or a single stage op amp. How we can overcome those things? Okay, that can be overcome through two stage op amp. Okay, here we are going to have an two amplifiers. Okay, in a stage 1 we are going to have an one amplifier and stage 2 we are going to have an another one amplifier. Okay, for example, you can consider at a single stage we can have a differential amplifier. At stage 2 we can have an common source amplifier. Typically most of the cases in the stage 2 we are going to use an common source amplifier to get a maximum swing. Okay, if we take a differential amplifier, there the swing may be less if you are using a cascade amplifier or anything to increase the gain. That's why at the output stage we will simply use a two-stage common source amplifier. Let us see the simple implementation of a two-stage amplifier. Just see this internal circuit. Okay, this is a single stage amplifier. This is the differential pair. Here it is an load M3 and an M4. It has been biased with an ISS current. This is a simple differential pair circuit, right? Okay, this is the first stage. Then the second stage is, here we have an two output differential output across Y and an X. It has been connected to M6 and an M7. Okay, here M6 is going to take an input and here M8 is been acting as a load with a constant biasing. Okay, this is a common source amplifier. You can see it, and this side we also having another one common source amplifier. This acts as a single stage. This M6 and M8 or M5 and an M7 acts as a second stage. This is going to produce an Vout1 and this is going to produce an Vout2. For this one it is going to take an input from this X terminal. M6 is going to take an input from an Y terminal. Okay, let us try to see that what is the gain in the first stage and what is the gain in the second stage. The first stage gain exhibits, as we already discussed, the gain that is nothing but an GM1 transconductance of an input MOSFETs and an resistance provided by an M1 MOSFET to the load. Okay, that is nothing but GM12 into R12 parallel with R03 R4. Okay, if you are identical, simply we can write it in this fashion. Okay, as you all know that in the second stage it is a common source of amplifier. It is simply GM into an RD. Okay, that is, if it has a channel length modulation effect, you are going to take R0, R6, comma R8, or you can take it simply an R5, comma R7. Okay, if it are identical, you can simply write it as an GM56 into RO56 parallel with RO7, R8. Okay, this is a simple implementation. Okay, if I take a simple differential pair, we are going to have a less gain. Okay, not to increase this gain, what we can use? Okay, we can simply use a cascaded stage at the first stage to increase the gain. At the output stage, simply we can use a common source amplifier. Let us see that circuit. Okay, this circuit is similar to our previous circuit. Only thing is, in the first stage we have been added within cascoded stage differential player. Okay, let us try to see the gain what we are going to be studied. I think I don't want to explain much regarding this, as we have been discussed in a single stage very detailedly of these circuits. The voltage swing and x and y are quite small. Okay, as you all know that if I use an cascaded stage amplifier here, I am simply going to get an output voltage swing less, but there is an increase in the gain. The overall gain can be expressed as, okay, first let us try to get the gain of our cascaded stage or an telescopic amplifier, that is an transconductance of this one into an resistance of transconductance of this one into an resistance of these two amplifier. Okay, for this M3 and an M4 we will be getting an body effect. That's why here we have an GM34 plus GMB34 then the RO34 into an RO12, then parallel with the transconductance of this one. Here it is going to have an body effect, that's why GM56 plus GMB56, and then resistance of this MOSFET 5 and then 7. If they are parallel identical, we can take 5, 6, 7, 8. Okay, this particular part is an gain from an cascaded amplifier. These things we have been already discussed. Then the gain produced from a common source amplifier. Okay, this is the input stage, that's why we need to take GM 9 or an 10 into an resistance of a 9 or 10 parallel with 11 comma 12. Okay, this is going to produce an overall voltage gain. Okay, if I use this circuit, we are going to get an I gain as well as I output voltage. Okay, let us try to see a two-stage op-amp with a single-ended output. Okay, here we want to get a single-ended output, means simply we are going to discard one of the output terminal, simply we are going to take the input from the other terminal. But the input stage is going to take a differential input, but output is going to produce with a single. As you all know that single-ended output means simply we are going to measure that output with respect to ground. Okay, this operates maintains and differential nature of the first stage using only the current mirrors M7 and M10 to generate a single output. That means here earlier we were biasing this M7 and M8 with an constant voltages. Here we have been using a current mirror circuit to get a single-ended output by taking it. Okay, it is going to, as we have been already discussed here, the voltage gain whatever it is going to produce, it is going to have a two-sided effect. If you see here that if you recall an active current load mirror circuit, okay, whatever the changes it is going to produce across this terminal, it is going to be reflecting across M7, the same will be reflecting across here. Then at the output stage it is going to produce a more swing. Okay, if you have any doubt regarding that one, please try to measure the video lecture of an differential pair with an active load. Okay, so that you can get clearly how it is going to produce an right output. Okay, in upcoming video lectures, let us see an how to increase and still gain of an two-stage op-amp. Thank you for watching.